Hello everyone, my name is Dr. N. Mangapathi, Assistant Professor in Mathematics Department, B.V. Raju Institute of Technology, Narsapur. Today I am going to explain matrices and basic concept of matrices. First, introduction of matrices. Matrices are used in real life for image process and computer designs and game theory, traffic and system of equations to solve the simple system of equations to convert it into. But first we are going to explain the basic definitions of matrices. Matrix is a set of group of numbers arranging in square or rectangle by enclosed by two brackets. Example, these are 1, minus 1 and 4, 3, 0. They are the examples. The elements are set and arranging in rows and columns. That array is called the matrices. Next, properties of matrices. A specified number of rows and specified number of columns. That two numbers are called columns or rows describe the dimensions of the size of the matrix. For example, 3 by 3 matrix. This is the how many rows? Row 1, row 2, row 3. And how many columns? First column, second column, third column. That order is 3 by 3. This is an example of the 3 by 3 matrices. Next, this is how many rows? 2 rows. 1, 2. And how many columns? 1, 2, 3, 3, 4. Therefore, 2 rows and 4 columns. Therefore, this is the example of the 2 rows of the 4 columns. And here 1 row and the 2 columns. Therefore, this is 1 by 2 matrix order. Next, the matrices are denoted by bold letters. The matrices are denoted by bold letters and the elements are denoted by the lower cases. Example, the matrices are denoted by capital A, capital B, capital C, capital X. The elements are denoted by small a, small b, small c, small x, small y, small z. These are the matrices. Example, therefore, the general form of the matrix is A11, A12, AIN and A21, A22, AIJ, A2N and so on, AM1, AM2, AIJ, AMN. Here observe that this is A11 is the first row, first column entry and A12 is the first row, second column. Aij is the ith row and jth column and Ain is the first row and A1i is called the first row and nth column. Here similarly observe that A21 means second row, first column. A22 means second row, third column and this is A2j means second row, jth column and A2n is the second row, nth column. This is a general form of the matrix. This is called first entry. This is a second, third, fourth entry. This is the order. How many rows here? 1, 2, 3, so on, m rows. How many columns? 1, 2, 3, so on, n columns. That is m by n matrix. The order of the matrix is m by n. This is a representative of the general form of the matrix. Therefore, I goes from 1 to m and j goes from 1 to n. Next, types of matrices. First, we discuss the column matrix, or this is also known as vector matrix. The column matrix are denoted that it has only one column. The type of matrix is called column matrices. Example, you observe that how many rows? 1, 2, 3, 3 rows. And how many columns? Only one column. What is the order of the matrix? This is a 3 by 1 matrix. Therefore, this is a column matrix. Another example, here 1 minus 3. This is 2 rows and only one column. Therefore, a matrix containing only one column, the type of matrix are called the column matrix. This order is 2 by 1 matrix. And here observe that general form of the column matrix is A11, A21, A23, so on, AMN. How many rows here? M rows. 1, 2, 3, so on, M rows. How many columns? Only one column. The order of the M by 1 matrix. Okay. Next we discuss row matrix. What is a row matrix? A matrix containing only one row. A matrix containing only one row. That type of matrix is called the row matrices. Example, observe that how many rows here? Only one row. How many columns? One column, two column and third column. Therefore, the order is 1 by 3. What is the order? 1 by 3. It contains only one row and 3 columns. Therefore, order is 1 by 3. Given another example, here observe that how many rows here? Only one row. How many rows? Only one row. How many columns? 1, 2, 3, 4. Therefore, order is 1 by 4. Next, here this is a general form of the row matrices. A11, A12, A13, A1n. This is only one row and the other column. Therefore, 1 by n order. Therefore, this type of matrix is called the row matrices. Next, types of matrices. Rectangular matrix. Okay, rectangular matrix is number of rows and not equal to number of columns. A matrix containing the number of rows is not equal to number of columns. The type of matrix is called rectangular matrix. Here observe that. Here observe what is here observe what how many rows? One row. 1, 2, 3, 4. How many rows? 4 rows. How many columns? 2 columns. Therefore, what is order? 4 by 2. Therefore, here how many rows? 4 rows. How many columns? 2 columns. Therefore, here observe 4 is not equal to 2. Therefore, the number of rows is not equal to the number of columns. Therefore, this type of matrix is called the rectangular matrix. Here observe that how many rows? 2 rows. How many rows? 2 rows. How many columns? 1, 2, 3, 4, 5. Here 5 columns and 2 rows. Therefore, the number of rows is not equal to number of columns. Therefore, this is the order is 2 by 5. This is also a rectangle matrix. This here m not equal to n. M denote the number of rows and denote the number of columns. These are both are not equal. That the type of matrix is called the rectangular matrices. Next, square matrix. Here clearly square matrix means the number of rows is equal to number of columns. In this matrix, number of rows is equal to number of columns. Both are same. Example, this is a order. The general representation of a square matrix is A m by m. That is m rows and n columns. Here observe that how many rows? 2 rows. How many columns? 2 columns. That is 2 by 2 matrix. And similarly, we get a 3 by 3 matrix, 3 rows and 3 columns. That is called the number of rows is equal to number of columns. Therefore, this is a square matrix. The principal or main diagonals of square matrix compose all elements A as A, where I equal to J. Next, diagonal matrix. Here matrix diagonals means every square matrix, a square matrix where all the elements are zeros except the main diagonal elements. That is, diagonal elements are not equal to 0. Remaining all elements are 0. That type of matrix is called diagonal matrix. Diagonals must be square matrix. Diagonals must be square matrix. Here observe that here 1. What is order? 3 by 3. How many rows? 3 rows. And how many columns? 3 columns. Here observe that the first entry is 1. The remaining rows are zeros. And the second, this is a diagonals. Only diagonal elements are not equal zeros. Remaining elements are all 0. Therefore, this is called the diagonal matrix. Another example, here observe that 3 0 0 0 3 0 0 0 0 5 0 0 0 0 9. Here only observe that here only diagonals are not equal to zeros. Remaining all elements are 0. Therefore, this is a diagonal matrix. Diagonal matrix, what is the condition of diagonal matrix? Aij. Aij means ith row jth column is zeros for I not equal to j. For example, this is what is the position of this element? Entry A1 2. Therefore, first row and second column, these are both are not equal, 1 not equal to 2. Therefore, this element are zeros. Here observe that what is the position this entry? A third row and third column, that is called A 3 3. That is 3 is equal to 3. In this case, I equal to j, the entry not equal to 0. Remaining cases are all zeros. That is called the diagonal matrix. Next, unit matrix. This is also called as identity matrix, denoted by capital I. Denoted by capital I. The diagonal elements are only 1. The diagonal elements are only 1. That is called, here observe that A 1 1 1 1. Therefore, this is called the diagonal matrix. So this is called the identity matrix. This is also known as unitary matrix. What is order? 1 2 3 4 1 2 3 4. Therefore, 4 by 4. That is I 4 by 4 order. Another example, here are 2 by 2 matrix. It is a 2 by 2 identity matrix. 3 by 3. For the general form of the identity matrix is Aij 0 0 Aij, and 3 by 3 identity matrix means 1 0 0 0 1 0 0 0 1. This is the 3 by 3 identity matrix. How to identify the identity matrix? The identity matrix means the diagonal elements, all the diagonal elements are is 1, remaining all are zeros. The type of matrix are identity matrix or unit matrix. Here observe that Aij equal 0, I naught equal j, Aij is equal to 1, Aij is equal to 1 for I naught, I equal to j. For example, this is called A11, this entry is A11, this entry is A22, this entry is A11, this entry is A22, this entry is A33. Okay. Next, null matrix. All entries of matrix in the matrix, all entries in the matrix are zeros. Example, this is called the null matrix. Null matrix is the column matrix or row matrix. This is called the column matrix because it has only one column. This is called null matrix of a 3 by 3 matrix, and this is null matrix. Okay, and row matrix, null matrix 0 0 0 0. This is called the null matrix of the row. Therefore, Aij, all entries are zeros. That type of matrix are called the null matrix. Next, triangular matrix. What is triangular matrix? The triangular matrix means a square matrix whose elements above or below of the diagonals, above or below of the diagonals are zeros. That type of all are zeros. That type of matrix are called the triangular matrix. Example, here observe that what is the diagonal elements 1 1 1 3. What are the diagonal elements 1 1 1. Above the diagonals are zeros. Therefore, this is called the triangular matrix. Another example, here observe what is the diagonals 1 1 3. Therefore, these are same example. Next, okay. Here observe the 1 8. What are the diagonal elements 1 1 3, and the below the diagonal elements are zeros. Below the diagonal elements are zeros. These are called the triangular matrix. Another example 1 0 4 5. This is also a triangular because this diagonal elements 1 5. The above the diagonal elements are zeros. Another example 1 2 0 5. This is also a triangular matrix. Therefore, diagonal elements are below the zeros. The triangle, there are the two types of triangular matrix. One is upper triangular, another one is lower triangular matrix. What is upper triangular matrix? A square matrix whose elements, the below the diagonal elements are zeros. Below the diagonal elements are zeros. That is called the upper triangular. This is a general form of the upper triangle. A11, A12, Aij. These are the diagonal elements below the zero. Example, here observe that what are the diagonal elements 1 1 1. They are the diagonal below the diagonal element. This type of matrix is called the upper triangular matrix. This is also upper triangle. What are the diagonals 1 1 7 3. They are the zeros. Below the diagonal elements are zeros. That is a general, that is a notation is Aij. Aij equal to 0 for all I greater than j. For example, this is a, what is the position of this entry? A21, that is second row, first column, that is greater than. Greater than means that answer is 0. For example, here observe that this is a, what is the entry of this element? A23, A32, that is 3 is greater than 2. Therefore, this entry is also 0. And example, this is what is the position 1 3, that is 1 is not less than 3, that is an element. And this is a lower triangular, means above the diagonals are zeros. Above the diagonal elements are zeros. That type of matrix is called the lower triangular matrix. They are the example. Here observe what are the diagonal elements 1 1 3. That are the upper elements are all 0. Diagonals above the all elements are there. Therefore, this is called the lower triangular matrix. That is Aij equal 0 is I less than j. I less than, I denotes the rows and j denotes the columns. And scalar matrix. Scalar matrix. What is a scalar matrix? A diagonal elements whose main diagonal elements are equal to same scalar element. Means that is the Aij, Aij, Aij. All are same. The diagonal elements are all same. For example, this is a diagonal matrix. That is 1 1 1. This matrix is called a scalar matrix. Here observe that 6 6. What are the diagonal elements? 6 6 6. Therefore, it is a scalar matrix. For example, give them example 1 0 0 0 2 0 0 0 5. It is a scalar matrix or diagonal matrix? It is a diagonal matrix. Only diagonal elements are remaining, all elements are 0. That type of matrix are called diagonal elements. The diagonals are all same. That type of matrix are called the scalar matrix. And matrix operations. Next we discuss the matrix operation. Okay, equivalent matrix. What is equivalent matrix? Equivalent matrix means the dimensions are equal. For example, A is equal to 1 0 0 2 1 0 5 2 3 and B is also 1 0 0 2 1 0 5 2 3. What is the order of the matrix? 3 by 3. What is the order of the matrix? B is also 3 by 3. The equal matrix means every corresponding entries are all are equal. 1 1 equal, 2 0 0 equal, 0 0 and 2 2 and 1 1 and 0 0. Every entries are equal. This type of matrix are called the equal matrix. A is equal to order 3 by 3. The equal matrix means order and same and every element entry are same. The type of matrix are called equal. For example, A is equal to, A is equal to 1 2 3 and B is equal to 4 5 6 8. What is the order of the matrix? 2 by 3. What is the order of A? 2 by 3. But order is same, but entries are not same. Therefore, A is not equal to B. Therefore, these are called the not equivalent matrix. Here, these are the equivalent matrix. Some properties of equality. If A is equal to B, then B is equal to A. All and of all A and B. If A is equal to B and B equal to C, then A is equal to C. For all A, B, C. Any matrix A, B, C. Okay. Then A is equal to B. For example, A is equal to 1 0 0 2 1 0 5 2 0 and B is equal, but A is equal to B. For example, given like that question, A and B are two matrices, the two matrices are equal. Then what is the B11 element is 1, B12 is element is 0, B13 element is 0. That is, this corresponding entries are equal. Aij equal to Bij. If A is equal to B, then what is the condition? Aij is equal to Bij. Addition and subtraction of two matrices. The sum or difference of two matrices A and B, the side of the matrix is same size. For example, here Cij is a resultant matrix and A is the first, Aij is the first matrix entry and Bij is called the second matrix entry. Then adding we get Cij. For example, A is equal to 1, 2, 3, 4 and B is equal to 2, 5, 6, 8. Then what is A plus B is equal to, if A plus B is possible, then the dimension is same. What is order of the matrix? 2 by 2. What is order of the matrix B? 2 by 2. Then A plus B is equal to, the corresponding elements are added 1 plus 2, 2 plus 5, 3 plus 6, 4 plus 8. We get answer is 3, 2 plus 5 means 7, 3 plus 6 means 9 and 4 plus 8 means 12. This is called the A plus B, that is called the C matrix. The matrix is C. What is order? We get same order. In commutative, in matrix the commutative law is satisfied. A plus B is equal to, with respect to plus, A plus B is equal to B plus A, and it also satisfy associative property. A plus B plus is equal to A plus B plus C, that is A plus B plus C. Here observe, this is a matrix. What is the order? 2 by 3. What is the order of the second matrix? This is A matrix, this is B matrix. The order is, this is also 2 by 3. That this is called the C resultant matrix. This is also order is 3. That is 7 plus 1, 8 and 3 plus 5, 8 minus 1 plus 6, 7, 5 and 2 plus 4 minus 4 minus 2, 5 minus, sorry, 5 minus 5 minus 2 minus 7, 6 plus 3, 9. Observe that A's order is 2 by 3 and B's order is 2 by 3. The resultant matrix also 2 by 3. A plus 0 is equal to 0 matrix. Any matrix add with 0 we get A, and A plus minus A is also 0. Scalar multiplication. If matrix A is a matrix, then multiply with K, we get AK is also both are same. For example, A is equal to, we get A is, if take one example, A is equal to minus 1, 3, 2, 4. Then scalar, take 3 into A, that is 3 into minus 1, 3, 2, 4. We get 3 into minus 1, minus 3, 3 into 3, 9, 3 into 2, 6, 3 into 4, 12. This is called the result, 3 into A. That is, if K is equal to 1, A is equal to 3, minus 1, 2, 1, 2, minus 3, 4, 1. Then Ka is equal to, that is K times into A is equal to K into K times equal to, we get 4 3s are 12, 4 1s are 4, minus 4, 4 2s are 8, 4 1s are 4, 4 2s are 8, 4 3 minus 3, 4 into minus 3, 12, 4 4s are 16, 4 1s are 4. That is, the multiply with constant with each and every entry, all our entries multiply with K, we get a Ka matrix. The properties of scalar multiplication, K into A plus B, we get Ka plus Kb. K plus G of A equal to Ka plus Gk, where K and G are the scalars. And K into AB is equal to K of A into B, K of K into A into K into B. And K of Ga is equal to Kg of A, where K and G are the scalars and A and B are the matrices. Multiplication of two matrices. The multiplication of two matrices means, if in addition the first matrix and second matrix have the same order, then matrix addition is applicable and exists. But in multiplication, that the first, the A and B are the multiplication exists if the number of columns of first matrix is equal to number of rows of the second matrix, then A and B are exist. The number of columns of first matrix is equal to the number of rows of the second matrix, then A into B exist. So the product of two matrices under A and B must be comfortable if multiple possible. The number of columns of first matrix must be equal to number of rows of the second matrix. For example, what is the order of the matrix? For example, take an example 1 by 3. And what is the order of the second matrix? 3 by 1. The rows of, how many rows here is the first matrix? 3. How many columns of the first matrix is 3? How many rows of the second matrix is 3? Both are 3 and 3 equal. The result matrix is 1 by 1. Okay. If a matrix multiplication exists, the first matrix column must be equal to second matrix rows, number of rows. Then the multiplication is exists. For example, here observe, what is the first matrix or columns? Number of columns of first matrix is 1, and number of rows of the second matrix is 4. 1 is equal to 4, not equal. Therefore, 1 not equal to 4. Therefore, not possible. Here observe that how many columns of the first matrix? 2. How many rows of the second matrix is 6? 2 is equal to 6, not equal. Therefore, not possible. Another example, the number of rows, number of columns of first matrix 3. The number of rows of the second matrix 3. Therefore, 3 is equal to 3. The resultant matrix is 2 by 2. Here observe that A11, A12, this is the order is 2 by 3. And what is the order is 3 by 2. The result matrix is 2 by 2. This is a general form of it. I will again example and explain. This is A matrix, this is B matrix. What is the order of the A matrix? 2 by 3. What is the matrix of B? 3 by 2. The number of columns of first matrix is equal to the number of rows of the second matrix. Therefore, 3 and 3, the result matrix is equal to 2 by 2. How to solve this problem? Means this is rows and this is columns. Now multiply 1 into 4 plus 2 into 6 plus 3 into 5. First row, first column, multiply each and corresponding elements entries are multiplied. 1 into 4, 2 into 6, 3 into 5. Next, same as it. Second row, first column. 4 into second row, first column. 4 into 4 and 2 into 6, 7 into 5. Similarly, first row, first column. First row, second column. 1 into 8, 2 into 2, 3 into 3, and second row, second column, 4 into 8, 4 into 8, 2 into 2, 7 into 3. We get that is 1 into 4. What answer? 4. 2 into 6 plus 12 and 3 into 5 plus 15. 15 plus 12 plus 4, that is 31. 1 into 8, 8 plus 2 into 2, 4 plus 3 into 9, that is we get 21. 4 4 is a 16, 2 is a 12, 7 3 is a 35. You can add, we get answer. The resultant matrix is 2 by 2. And remember, I is the identity matrix. Any identity matrix multiply with any matrix, we get same matrix. 1 I into B, what we get is also B. What is answer? 1 0 0. This is called the identity matrix. This is another one matrix B. We get 31, 21, 63, 57. We get same matrix. And A into I is equal to some properties. A into I is equal to I into A, that is called A. A into B into C equal to A into B into C, A into B. And A into B plus C, this property is called the distributive property. This property is called the associative property. And A plus B into C equal to A into C plus B into C. But in multiplication, AB is not equal to BA. In multiplication, AB is not equal to be commutative, not satisfying matrix. AB is generally equal to BA, but BA is not equal to comfortable. If A into B equal to 0 means neither A or B necessarily equal to 0. A into, what is that example taken? One example, T is equal to 1 to 0 5. What is the order? 2 by 2. 2 by 2. What is S order? 2 by 2. Therefore, the number of columns of first matrix and the number of columns of the rows of the second matrix both are same. That is the how to explain this is 1 into 3 plus 2 into 0. First row, first column. Again, first row, second column. 1 into 4 plus 2 into 2. Next, 5 into 3 plus 0 into 0. Next, 5 into 4 plus 0 into 2, that is 3 1s are 3, 4 1s are 4, 2 2s are 4, that is we get answer is 8. The result matrix is 1 plus 0, 4 plus 4, 15 plus 0, 20 plus 0. We get 1 plus 3, 3, 4 plus 4, 8, 5, 15 plus 0, 15, 20 plus 0 is 20. And similarly, you can do S into C. We get 23, 6, 4. Therefore, TS is not equal to ST. In matrix multiplication, commutative is not satisfied. A into B equal to 0. Next, we discuss transpose of matrix. Transpose means interchange the rows and columns of the given matrix. That matrix is called the transpose matrix. For example, what is the order of the matrix? 2 by 3. That is how many rows? 2 rows. How many columns? 3 columns. What is the order? 2 by 3. Then transpose is row interchanging rows and columns, that is 2 5 and next 4 3, next 1 3. Therefore, what is order? 3 by 2. For example, A is order is 5 by 4. What is the transpose matrix order? 4 by 5. Interchange the rows and columns. Aij is equal to A transpose element is Aj1. That is interchange the rows and columns is called the transpose matrix. Here A transpose equal to, this is the example. What is the properties of transpose matrix? A plus B whole transpose is equal to A transpose plus B transpose. AB whole transpose equal to B transpose into A transpose, because in AB whole transpose equal to B transpose into A transpose, and K into transpose, where K is a scalar multiplication, then K into A transpose. A transpose whole transpose equal to, again example, A is equal to 1 2 3 4 5 6. What is the order of the matrix? 3 by 2. Then A transpose means what we get? 1 3 5 2 4 6. Again transpose we get, this is order is 2 by 3. Again transpose we get 1 2 3 4 5 6. What is the answer? 3 by 2. That is all A. A transpose whole transpose equal to A. Again example, A plus B whole transpose. This is a matrix. This is a B matrix. The result matrix is C. Then after transpose we get A. Interchange the rows and columns means we get, this order is 2 by 3. Again transpose we get 3 by 2. This is our first left hand part. Then A transpose, and A is a transpose. This is called A transpose plus this is a B transpose. we get 8, 8, 8. Therefore, these are both are same. Therefore, A transpose plus B transpose equal to A plus B whole transpose. Here, AB whole transpose equal to B transpose into A transpose. This is a matrix, this is a B matrix, this is a multiplication. What is the order of the matrix? 2 by 3. What is the order of the matrix? 3 by 2. The number of columns of the first matrix is equal to number of rows of the second matrix. Therefore, the matrix multiplied. What is the resultant matrix order? That is the result 3 by 1. The result matrix is 2 by 1. And the order 1, 1, 2. That is the order of matrix 1 by 3. What is this order? 3 by 2. The result matrix is 1 into 2. A into B, we get 2, 4. And B transpose into A transpose, 2, 4. Both are equal. Symmetric matrix. What is symmetric matrix? A square matrix is said to be symmetric if A transpose equal to A. If A transpose equal to A, that type of matrix is called symmetric. A square matrix said to be symmetric means if it is a transpose or equal, A transpose equal to A. That is example, A equal to AB, BD. Then A transpose equal to AB, that is called A. For example, I give you an example, 1, 2, 3, 2, 3, 4, 2, 2, 6, 4 and 3, 4, 5. And transpose, to find the transpose, A transpose equal to 1, 2, 3, 2, 6, 4, 3, 4, 5. Therefore, A transpose equal to A. Therefore, A is a symmetric matrix. Next, skew symmetric matrix. Skew symmetric matrix means a square matrix said to be skew symmetric matrix if A transpose equal to minus A or A transpose equal to minus A. Okay, satisfy this condition, the matrix is called a skew symmetric matrix. Example, what is A matrix? 2 by 2 order. What is the matrix? 0, B, minus B, 0. And A transpose is, that is 0, B, minus. Take minus common, we get 0, B, minus B, 0. This is called minus of A. Therefore, A transpose equal to minus A. In skew symmetric, you observe that the diagonals, all the diagonal elements are zeros. For example, we give 1, minus 2, 2, 4. Then A transpose, what is the element? 1, 2, minus 2, 4. Take minus common, we get minus 1, minus 2, 2, minus 4. This is not equal to, here A is equal to 1, minus 2, 2, 4 and A transpose 1, 2, minus 2, 4. But here take minus common, this is not equal to A. Therefore, it is not a skew symmetric matrix. In skew symmetric matrix and symmetric matrix, we observe that in skew symmetric matrix, the diagonals must be zeros. Next, determinant. Determinant matrix. Determinant matrix denoted by every square matrix A has a unit scalar multiplication is called the determinant. Determinant means mod A or det A. This is called, for example, A is equal to A, B, C, D is 2 by 2 matrix. What is det A formula? A into D minus C into D, that is AD minus BC. AD minus B. What is that? This is A is equal to 2 by 2 matrix. The det A is equal to 1, 2, 5, 6. What is the determinant? 1 into 5 plus, 1 into 5 minus 6 into 12. That is 5 minus 12. That is minus 7. The determinant means Aij. Example of determinant. Each element of A has a minor. Delete the first and first column of this matrix. For example, to find the A, then delete this row and this column. That is 2 by 2 matrix. I give an example, I explain. Okay. This is the determinant. The determinant of M by N. This is a square matrix below. Det of A equal to A11, C11, A12, C2, A12 and A1 and C1. C11 means cofactors. This is determinant. 3 into 2 minus 1 into 5. 6 minus 1 is equal to 5. For example, A is the 3 by 3 matrix. How to find the determinant? This is a 3 by 3 matrix. The det A is equal to, what the first element is 1. Delete the row and column. What is the elements? 2, 3, 0, 1. Next, take minus. Every second row or second column might take as a opposite sign. Minus or take plus or take minus. That is in minus 0. remove this row, this column. That is 0, 3, minus 1, 1. Next, plus determinant of exponent of 1, that is 0, 2, minus 1, 0. That is 1 into, what is the formula? AD minus BC. 2 minus 0, minus 0 into any number, 0 minus plus 3 plus 1 into 0 plus 2, that is 2 minus 0 plus 2, that is called 4 is the answer. Next, A inverse. What is the form of A inverse? A inverse equal to adjoint A into A. If A is equal to 1, 2, 3, 4, then A inverse equal to 1 by det A. What is the det of this matrix? That is equal to 1 into 4 plus 3 into 6. 4 plus 6, that is called 10. And if A is equal to A, B, C, D, then A inverse formula is 1 by AD minus D minus B minus C A. This is a matrix. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.